Welcome back, everyone. Hope you got your coffee, tea, water, or whatever your favorite drink is, and are ready for our next session, which will be led by Mariela Castano, Senior Vice President and COO of Kunst Solutions. She will discuss how micro-stoppages in the food industry refer to very brief and often unnoticed interruptions or pauses in the production process that occur repeatedly and frequently. These interruptions are typically short in duration, often lasting just a few seconds to a minute, and they may seem insignificant on their own. However, when these micro-stoppages accumulate over time, they can result in significant overall downtime, reduced productivity, and increased operational inefficiencies. These interruptions can be especially detrimental in organizations that rely on continuous or high-speed production lines. During these sessions, she will share how to effectively implement a strategy to manage and eliminate micro-stoppages. Mariela is an industrial engineer by trade. She has over 35 years of experience in operations, manufacturing, and continuous improvement. She has worked for Kraft in their coffee division as a manufacturing engineer and leader of continuous improvement. She has also worked at Nestle Waters as a regional continuous improvement manager. Mariela is a Six Sigma black belt with a passion for working with less and a sharp eye for waste reduction. Mariela is able to identify what's important to an organization, and at the end of the day, that's the bottom line. After Mariela has finished her presentation, we will once again open the virtual floor for questions. As a reminder, if you have any questions during or after the presentation, as before, please post them in the Zoom questions box. Over to you, Mariela.
Good afternoon, everyone. I'm really excited to be this afternoon with you and to have the opportunity to share some of my experiences and the knowledge related with micro-stoppages. And this is one of those topics that not many people talk about, but that we all experience every day in each one of our organizations. So I'm going to go from a very high level to a very low level, and I'm hoping that you can go along with me and that I have the opportunity to create a higher level of awareness for what micro-stoppages can do or are doing to your organization today. So I'm going to start by sharing the agenda. It's going to be very simple. I want to show you a strategy for the reduction of the micro-stoppages. Is one of those taboos at many times for many organizations, and I want to show you that it's not as difficult as some people think that it is. Along with that, I want you to discover and clarify possible those questions that you might have or questions that your team members had brought to your attention, and that by giving you clarity on some of the events that happens every day in your organization, that you're able to answer to your team members those questions, and that you're able to answer to your financial books the explanations on why sometimes things don't look so good. So I want to start by going over the understanding of the difference of two very important topics. And I want to make a clarity here on what slow speed is versus micro stops. And the reason is very often I see that organizations confuse what slow speed is with micro stops. And the difference is very clear. When we look at slow speed, we see that the machines or the production lines are running slower than the target run rate. So yes, once we design a process and our engineering team defines this is the run rate at which the equipment should be running at, sometimes we see that we are running lower than that, slower than that. And sometimes we opt that that is acceptable because the constraints that we have with either the variability in the equipment, the variability in the labor, the materials, or so on, or simply because we don't have the demand and we agree that we are going to run our lines at a lower speed. However, when we look at the micro stops, then microstops relate to machines or production lines that stop briefly and frequently. And this is where things get complicated because often we are too busy running around our plants. We don't stop and we don't see that these stoppages are happening. They are so brief that within a blink, you don't realize that they are happening. But in high speed lines, when we're talking about production lines that are processing products at 1,000, 2,000 units a minute, well, these micro stoppages count. So they often go unnoticed. And today, I want you to start noticing them. And why is that I think is important for you to notice them? Well, because they cost money. They cost a lot of money. And I'm sure that you're saying, yes, of course, I know, I understand that that is obvious. But when you start looking at cost and that dollar figure from a different perspective, maybe you're going to get more motivated to look at the micro stoppages differently and to start acting on them. What do I mean by that? Well, there is significant overall downtime. So imagine if there is a micro stoppage that only takes few seconds, but you run hours, days, and years of production, those seconds become minutes, hours, and days of downtime. Often we respond when a machine goes down, all maintenance, hands-on, team members, everyone is like, oh my God, we have to deal with this. But we don't do the same when there are micro stoppages. We just walk by them. We just unjam the line. We just figure, well, it's normal. That's how the line runs. And I'm going to tell you, it's not. When you start calculating the amount of time that it takes, it becomes a big, big number in your overall downtime. The second aspect is because it affects increased operational inefficiencies. So we often just troubleshoot, and that troubleshoot becomes in rework, and that rework then turns into poor quality. Well, I can tell you, we have identified that around 60% operational efficiencies are due to micro stoppages. And then how about productivity? Well, productivity gets reduced dramatically. The lower or constrained capacity equals lower profits. And we have seen time and time and again when we get to quantify the micro stoppages that productivity in many organizations gets affected up to 80%. That is huge. It's huge. Now, I have a problem when I work in an organization and I see a high speed line that is constantly stopping, dealing with micro stoppages. And in the other hand, I have an engineering team or a very excited manager saying, well, I need more CapEx. I need to buy a new line. We don't have enough capacity. Guess what? If you go back and you look at those micro stoppages, I can guarantee you, you do have capacity, lots of capacity. Reduce your overall downtime equals capacity. Increase your operational efficiencies, and you're going to find capacity. So that productivity and those profits go hand on hand. You know that. So look at your micro stoppages because they indeed cost you money. So we said there is a lot of money within micro stoppages. So what do we do about it? We need to quantify it. And how do we quantify micro stoppages? Well, my friends, there are different ways. The first one is creating or putting in place tracking downtime logs. And I'm sure that many of you have them. Either they are highly automated, connected to the PLCs of your equipment, or there are something as simple as a piece of paper where people are writing the micro stoppages or their downtime and the number of occurrences that happen. It's just that, guys. It's as simple as that. Now, within the food industry, the investment in CapEx tends to be high every time. It's one of the most modernized industries, if you think about it. The amount of dollars and engineering that are required to run a production plant are significant. So chances are that you have the technology available to plug in electronic systems to give you data. If not, I'm sure you have labor around that can take that information for you. So tracking the downtime is extremely important to measure something. What? The impact of the micro stoppage to your downtime, the impact of the micro stoppage to your productivity. So I'm not asking you to measure just to measure, to quantify just to quantify. I'm asking you to measure to identify the impact in the overall business performance. Now, when we look at measuring that impact, then we want to calculate the cumulative losses. What do I mean by that? You need to classify that information that you are collecting. And you need to, as you classify that information, quantify it. Number of events or time that you are capturing. And with that, you are going to realize how those short stoppages are taking so much of your overall downtime, of your overall losses. So understand that the data is there and that the data, if you look at it and you look at it from different perspectives, will speak to you and will speak to you very loud. Now, dealing with the elimination of micro stoppages can also be expensive, but there are many ways to deal with it in a not so expensive manner. How can you establish how much to invest on it? Well, you first of all have to figure out how big your problem is. Collect data, analyze it, quantify it. Now, it's important to identify the root causes of the micro stoppages. You have quantified them. All right, we know how big our problem or our opportunity is. Now, the question is, where are they coming from? So, the causes of micro stoppages are from different sources. The most common and obvious, and the one that everyone kind of relate with, is inadequate maintenance. Yes, I know we spend a lot of money in maintenance. It's usually one of the biggest line items in everyone's budget, but often it's not the right maintenance. So the equipment fails. So the equipment stops. So the equipment micro stops and it kind of passes in front of us and we don't see that it's not performing properly is due to inadequate maintenance. But is maintenance the only reason? No, of course no. We have poorly trained and inexperienced team members. It's a big, big factor within micro stoppages. New people to the organization don't know what they don't know. People that have been in the organization for a long period of time but have not been properly trained, they don't know what they're looking for. So a process that is constantly stopping to them is a normal process. It's been like that since I was hired. So it's the norm. That is a big cause of micro stoppages because if there is no awareness, there is no need to end it. The next one is quality control issues and quality significant aspect within the food industry. We know that we're trying to prevent recalls. Food safety is number one in our action item list, but very often we use those controls to monitor micro stoppages. Very often those quality controls create micro stoppages because quality imposes a check and very often works with engineering, works with maintenance to figure out how that check can happen without having to stop the equipment, how that check can happen without causing an upset on the equipment. The next one is inefficient changeover processes. It's very, very sad to see that even though within the food industry we go through hundreds and thousands of changeovers day over day, but we don't seem to be very efficient always at them. And it's our livelihood. Come on, it takes capacity, right? But we're not so efficient at that. And another one that is a big one is the lack of standard operating procedures. For some reason, we still believe that tribal knowledge is the way to run the business, and it's not. There is a huge, huge amount of knowledge on our team members' brains, on our leaders, team leads' brains, that doesn't make it to a standard operating procedure. So everyone has a different way to run the business, a different way to run the operation, a different way to set up the machine. That variability increases the amount of micro stoppages that happen. So there is another one, a big one out there, big cost, and that one is poorly engineered processes. And I'm not ashamed to say that. I am an industrial engineer myself. I design processes, and the processes make sense to me, on my mind, on my computer models. But once those processes are implemented, they might not make so much sense to the operators that are running the equipment or to the maintenance teams that are in charge of making sure the equipment is up and running at all times. And how do we know that we have poorly engineered processes? Well, because we experience jams, lots of jams, guys. So if you walk through your plant and you see that those bottles are not moving, that conveyors are stuck, that air bayers are stuck, bottles are dingling, packages are falling off the conveyor, that is because we have jams, meaning we didn't design, we didn't engineer our process properly. Our equipment has an opportunity to be revisited, to be re-engineered. So knowing the causes for the micro stoppages is good. Now, what do we do? Well, guys, we have to reduce it. And for that, then there is a strategy. Very simple, and that's what I'm going to share next. So the strategy starts by using data to approach the understanding of the micro stoppages and to address the micro stoppages. So we said, well, stories take us a long way. We are very emotional about we run our business. But when it's about micro stoppages, only data. You need to use data to drive your decision making. The next one is effective maintenance. And boy, effectiveness has many definitions. We'll check some of those definitions shortly. The next one is team member training and empowerment. So important that our team members learn how to develop eyes for flow, eyes for waste, and how to target, understand, and address micro stoppages. The next one is optimizing quality control. So often we see quality as is this so important aspect of our business that can be a little bit of a pain because it adds work, it adds time. Well, if you look at your quality control system and you optimizing geared to the identification and the elimination of micro stoppages, you have one of your best allies there. Your quality team in conjunction with your maintenance team and your engineering can make wonders. The next one is to streamline your changeovers. I mean, guys, capacity equals cash. We just talk about it. Externalizing whatever you can, the most that you can to externalize and minimizing that downtime. And then comes along your standard operating procedures, right? So bringing the standardization on how we do things, how the process needs to be run, within the specific limits. So if everyone works within the same limits and something deviates, we have the opportunity to identify it. We have the opportunity to address it in a very, very proactive manner. When we talk about data-driven approach, well, I'm talking about start using those skills that I'm sure you have invested on with many of your team members. And also, and we're talking about monitoring the equipment performance, using data to see the uptime, the downtime, the frequency of the issues that we're having, speeds, feeds, ins and outs. All these are so important. And most importantly, identifying the patterns for the micro stoppages. So things like time of the day, things like who is running the equipment, things like what product are we running. All those will give us patterns where we can say, hey, at this time of the day, maybe we are getting affected by the fluctuations in hydro because there are other 10 companies, 10 factories in my neighborhood that are sucking up power and are affecting my equipment. What can we do to change that? So it's really, really important to gather that data so you have visibility on how the process is performing. What do we do with that then? Well, we are able to pinpoint the root causes of the micro stoppage, but most importantly, implement targeted solutions. And I want to be specific about that. Targeted. You cannot just make a statement, a blank statement, and say, this is how I'm going to address micro stoppages. We're going to do only this. No, you have to be specific. Where in the equipment, which machine, which driver, what product, what sensor is the one that is not responding. Like, you have to be very targeted. So that's why that data collection is so important, because it allows you to start seeing the trends, and then you can deep down to identify the precise point where the problems are coming from. Now, effective maintenance come along. So here is where maintenance is not just maintenance. We need to look at maintenance prevention. So eliminating the need for maintenance tasks through the modification of the equipment. We're looking at preventative maintenance, which is eliminating the need for maintenance tasks through the modification of equipment. Two very different things, right? We want to modify the equipment, and we want to be able of looking at the tasks that can be performed to prevent the failures. The next one is monitoring the condition prior to failure, predictive maintenance. And then we are looking at setup reduction, which we just mentioned is reducing the equipment downtime from the last good part to the next good part that we're running. And how about spares control? It's amazing how many millions of dollars organizations spend on spare parts, and often there are not the right ones. Often the team members are using the wrong ones, or often they get damaged during installation. So looking at making spare control more holistic will help you with the reduction of micro stoppages. And now, AI. No more or no less than using AI to detect abnormalities, patterns, and trends to understand the equipment behavior. Yes, that's what AI is going to do to you. It's going to allow you to understand how the equipment behaves, define those patterns so you can create that scope of work. Now, focus training. And when we look at focus training, then what we want to do is the obvious, ensure that our team members know how to deal with the equipment, how to use it, and how to troubleshoot. Many of you do it, and good for you. Keep doing it. Identifying and addressing the micro stoppages promptly. That's a little bit harder. So we need to teach them the root of the micro stoppages so they know how to address it. We need to provide them the right tools. We need to create escalation protocols so they know if my micro stoppage is going over this amount of minutes, this is what I need to do. And now the most important one is stopping the line. We need to give empowerment to our team members to stop the line. They identify micro stoppages too often, too many of them, stop, so we can figure out what's wrong, we can address it. And my most favorite one, zero adjustments and center lining. Most of organizations suffer of adjustitis. Our team members start their shift and they go and adjust the machine. They go to break, someone comes to relieve them, and what do? They adjust the machine again. And then the next person comes back from break, and what are they doing? Readjusting the machine. They're moving the center line further and further every time, causing micro stoppages. And for that, I'm going to prove you that there is a way to deal with it. So how do we deal with it?
A thought experiment popularized by Dr. W. Edwards Deming, called the Nelson funnel, demonstrates the importance of not making adjustments to an in-control process. In the experiment, a funnel is positioned a few inches above a flat surface. There is a target directly under the funnel. 100 marbles are dropped through the funnel to try to get as many marbles as possible on or near the target. When a marble is dropped through the funnel and lands on the surface, it will always roll an unknown distance in a random direction. If we leave the funnel completely still and don't adjust it at all, the resulting marble locations will be pretty widely distributed in a rough circle around the target.
You see? As simple as that. Stop making adjustments and you're going to reduce micro stoppages. There is the reasoning behind it. Well, and we cannot forget optimized quality control. And what do we mean by that? Having a robust quality control measurement system and to ensure that we can reduce repeated checks. You know, sometimes those checks are not needed. Let's evaluate what do we need really and how we can perform the best with the resources that we have without increasing the stoppages on the equipment. But also automating inspection systems. Guys, again, you spend millions of dollars on equipment. Let's use the technology that is out there to allow us to minimize manual interventions. Now, when we look at the changeovers, streamline those changeovers. So this graphic shows graphically the sequence of events during a changeover and the time that it takes. And it happens that we are running full production at full speed. We realize we need to make a changeover and we start ramping down. And as we ramp down, then eventually the line stops. And then, oh, we're ready for the changeover. Let's go and start changing parts. And then when we think that we're ready, the line starts and it slowly starts. And when we finally achieve steady production, we said, well, we have ramped up. Now the line stop ends. But during that entire time, we lost production. That loss is significant. People only look at the losses when the machine is down. They don't realize the losses when the ramp down is happening and when the ramp up is happening. They can be even bigger than the losses than when the machine is down. So my message to you is reduce the downtime during the transitions. Ensure that there is a smooth changeover. Understand that the changeover should be captured from the last good part to the first good part, running at rate within quality specs. Not just running at the right rate. and making sure that it's 100% the quality expected. So look back at that chart, don't forget what happens within it, and turn that big U into a V to reduce your downtime. Next, we have the SOPs. So use SOPs to incorporate best practices. Make sure also that you are incorporating lessons learned. And that takes me to the next thing, and is developing that improvement culture. So we can inspire our team members, inspire to have organizational alignment with our objectives, uptime, reducing of micro stoppages, and to inspire them to desire to identify and address those micro stoppages. They have to understand how they affect them and the performance of their teams. With that, then, we can also foster a much more proactive problem-solving culture. Finally, I want to leave you with a thought. I know that each one of your organizations is going through that constant of pursuing of the perfect process. And we achieve it if we don't have disturbances to flow. And how do we eliminate those disturbances to flow? By eliminating the micro stoppages. So with that, I want to open the floor to questions. I'm hoping that I was able to give you a high-level overview of what micro stoppages are and how bad they are to your organization and the opportunities that you have in front of you. Thank you.
Thank you very much, Mariela. Lots of great information. We now have some time for the question and answer part of the session. For those who haven't already, please post your questions in the questions tab below. A couple of questions that have come in. Can micro stoppages happen in manual processes?
Yes, they can. And like in high-speed lines, they happen so often that people don't realize that they are happening. A good example is when there is a team member performing a task and they go and grab something, or they have the tools that they need beyond 30 inches of reach. So every time that they have to extend their arms, every time they have to turn or twist, that they're not touching the product that they're working on, there is a micro stoppage happening.
Okay. Why do organizations ignore micro stoppages?
Because they believe that micro stoppages is the way how the business ran, is part of the process. Micro stoppages often happens from the very, very beginning. As I said, when we engineer the process, the micro stoppage is conceived. So the organization sees it as normal. And it happens because leaders have blind eyes. So my message to my leaders is, go to the Gemba, go where the activities are happening, stand there, tune yourself off of everything else, focus on the equipment, and you are going to see those micro stoppages, and you are going to realize that you cannot ignore them. They're big.
All right, we got a couple more minutes. Last chance to send in your questions. Here's another one. How can I best lead the identification of micro stoppages?
So leading by example is the best way. Is as you learn how to identify the micro stoppages, how to see them and not ignore them, and when it's clear to you and it's in front of your eyes and you're perceiving the effect of them, start bringing your team members on board. Do waste walks. Show them and teach them how to identify and eliminate them. Go through those causes and explain them, and it's really, really holding their hands. Our team members don't know any better. It's normal today to them, so you need to kind of shake their word and show them. It's the best way, leading by example.
I guess one question would be, what would you think, what would you say is the most important thing that attendees should take away from your presentation today?
Understand that micro stoppages are part of your life and you're ignoring them. I think that the most important thing is just don't ignore them. Go and I call it the voice of the process. Hear the voice of the process. Every time that you see one, the process is screaming to you that there is something wrong. And that wrong is money, guys. Money taking your capacity.
Okay. And I guess that was the last question. So thank you again, Mariela. That was a great far-reaching session. Thank you for joining us.
Thank you. My pleasure.